In this tutorial, we're going to take a look at long division when you're dividing by a two-digit number. And it's really very similar to when the divisor is a single-digit number, but there are some very small differences. So I thought I'd do a video with a couple of, well, 4 examples when the divisor has 2 digits, 12, 21, 16, 30. So let's start with the 167 divided by 12. So we write it like this. You're dividing by 12, so 12 goes over here, and 167 inside the division symbol. So now one's minor difference when you have 2-digit divisor as opposed to 1, you don't worry about dividing 12 into the first digit. 12 can't go into 1 because the divisor has 2 digits, so you would automatically look at the first 2 digits here. 12 can go into 16. So let's write the first few multiples of 12. 12, 24, 36. So we're dividing 12 into 16, and 16 is between 24 and 12 here. So it will go in once with a little bit left over, but it won't go in twice or more. So it only goes in once. So we put a 1 above the 6 here, and 1 times 12 is 12. And we're going to subtract, so 16 minus 12, or 6 minus 2 is 4. 1 minus 1 is 0, so there's nothing written here. And then we bring the 7 down. So how many times can 12 go into 47? Well, if we actually wrote the next multiple of 12 here, after 36, it's 48. So the next multiple is just a little bit bigger than 47, so 12 won't quite go in that 4th time. So 36 is the lower multiple. So it's the 3rd multiple, so we would put a 3 here. 3 times 12 is 36, so put 36 here, and subtract. So 7 minus 6 is 1, 4 minus 3 is 1, so there's 11 here. So that's the remainder. The remainder is just, well, 1 below what the divisor is, so that's the highest the remainder could ever be, 1 below the divisor. So 13 remainder 11 is the answer, so we would write up here 167 divided by 12 is 13 remainder 11. Okay, number 2 here, we're dividing 891 by 21. So let's write the division. So let's write the first few multiples of 21. 21, 42, if we add 21 to this. Notice each time when you're adding 21, 20, the tens digit goes up by 2, and you're adding 1 to the 1, so the ones digit goes up by 1 each time. This would be 4. The 10 digits go up by 2, so that would be 84. So notice that we're dividing 21 into 89, and 89, well, it would be the next, it's the next multiple of, I didn't write the 5th one here. I guess I could write it. So if we add 21 to this, the next multiple would be 105. So the 89 is between 84 and 105. So it's going to go in 4 times. So we bring a 4 down. 4 times 21 is 84. So we put 84 here, and we subtract. 9 minus 4 is 5. 8 minus 8 is 0, so we just write the 5. And we bring the 1 down. So how many times does 21 go into 51? Well, 51 is between 42 and 63, so it only goes in 2 times. So we go to the lower multiple. So we would put a 2 up here. 2 times 21 is 42. So we put 42 below the 51, and we subtract. You would actually have to borrow here. So that 5 is going to become a 4. We borrow to put a 1 there. So we're actually subtracting 2 from 11, which is 9. 4 minus 4 is 0, so you don't bother writing anything there. And so we're finished because we brought the last number down here. So the remainder is 9. So 891 divided by 21 would be 42, remainder 9. On to the 3rd one here. We're dividing 752 by 16. So let's start by writing out the first few multiples of 16. 16, 32, 48, 64 is the 4th one. We add 16, so you see you add 6 to 4, you get 10, so it ends in a 0. And you carry the 1, so 6 and 1 more makes 80. 80 plus 16 is 96. 96 plus 16 would be 112, etc. So there's the first, I guess, 7 multiples of 16. So we're dividing 16 into 75. So 75 is between 64 and 80. So we'll go in 4 times with a bit left over. So we put a 4 up at the top here. So 4 times 16 would be 64. And we're going to subtract. So 5 minus 4 is 1. 7 minus 6 is 1. So there's 11 here. And we bring the 2 down. So the reason I listed out to 7 is because I need up to 112. How many times does 16 go into 112? It goes 1, 2, 3, 4, 5, 6, 7. It actually goes evenly 7 times. So we put a 7 up here. 7 times 16 would be 112. We subtract the remainder 0. So we can put our 0 here. When the remainder is 0, you don't have to actually write that, but there's nothing wrong with writing it there. So 7052 divided by 16 would be 47, remainder 0, or exactly 47. Okay, last example here, number 4, we're dividing 6,151 by 30. So let's write out the division. And it'll be convenient if we have the first few multiples of 30 written here. So 30, 60, 90, 120. That's the first 4. And so we're dividing 30 into 61. So 61 is just, well, 1 bigger than 60, so it'll go 2 times with 1 left over. So we'll put a 2 up here. 2 times 30 is 60, and we subtract. 61 minus 60 would be 1. So we bring the 5 down. And I wanted to do this example because this shows something that does happen once in a while in long division, not a lot. But I brought the 5 down, but see, 30 does, even though this is a 2-digit number, 30 doesn't go into 15. Because 15 is smaller than 30. So that will happen once in a while. It's not rare really, but it doesn't happen too often. So if that happens, then put a 0 here, and you need to bring the next digit down. So this division, even though they're pretty big numbers, it's actually going to be fairly short. So you ask yourself now, how many times does 30 go into 151? So we need a few more multiples of 30 here. 30 add to 120 is 150. Plus 30 more is 180. So 151 is between these. Well, it's just 1 bigger than 150. So 30 is going to go into 151 1, 2, 3, 4, 5 times with a little bit left over, a very little bit. So we'll put a 5 here. So 5 times 30 is 150. We subtract. Well, you just get 1. So the remainder is 1. So the answer to this would be 205 with a remainder of 1. So that's how you do long division. And also with his example here, what happens if you bring a digit down and the divisor doesn't go into it? You just put a 0 and then bring the next digit down. So that's all you have to do. So that's the end of the tutorial and how you divide with a 2-digit divisor.